All right, let's get right into it. For millions of years, our planet has followed this incredibly predictable rhythm, a kind of cosmic beat that plunges the world into ice and then, just as predictably, pulls it back out. But what happens when that rhythm gets broken? Today, we're tackling one of the biggest questions in climate science: when is the next ice age due? And let me tell you, the answer is a wild story about celestial mechanics, a canceled appointment, and a potential planetary glitch that nobody saw coming.
Now, I know exactly what you're thinking. We are living through the hottest years on record. An ice age sounds like the absolute last thing we should be worried about, right? Well, that paradox is precisely why this is so fascinating. It shows that we're dealing with these huge, competing forces on completely different timescales. And our actions today, they're setting off a chain reaction that's going to echo for hundreds of thousands of years.
So, to figure out where we're going, we first have to understand the planet's natural pacemaker. See, before we humans started messing with the atmosphere, Earth's climate was governed by this beautiful, predictable celestial dance. This is the cosmic clock that has been ticking away reliably for over 2.5 million years.
And that clock is driven by something called Milankovitch cycles. Now, these aren't random. They are slow, regular wobbles and shifts in Earth's orbit around the sun. You can think of them as the master control system for the planet's climate, dialing the sun's energy up or down over immense stretches of time. And ultimately, they're what decide when massive ice sheets get the green light to grow.
Okay, let's break this down into its three main parts. First, you've got eccentricity. That's just the shape of our orbit, stretching from a circle to more of an oval over a 100,000-year cycle. Then there's obliquity, which is the tilt of Earth's axis rocking back and forth. That one takes about 41,000 years, and it controls how extreme our seasons are. And finally, there's precession, a slow wobble of the axis, kind of like a spinning top, which changes which season gets the most intense sun. The bottom line is when you combine these three cycles, they determine how much summer sun the northern hemisphere gets. And that right there is the trigger for an ice age.
So where are we on this cosmic clock right now? Well, as it turns out, our orbit is nearly circular, and our axial tilt is actually decreasing. Both of these things mean less summer sunlight up north. So according to this natural clock and this clock alone, Earth should be on a slow, gentle slide toward the next big freeze. The stage is basically set for a new ice age to begin.
But here's the first major plot twist. Just as the planet was supposed to be cooling down, a brand new force emerged on the scene: us. We have become so powerful that we have, for all intents and purposes, broken this ancient cosmic clock. To get a sense of just how huge our impact is, just look at this. For hundreds of thousands of years, CO2 levels would go up and down naturally, but they always stayed within a pretty tight range. Then the Industrial Revolution happened. We've injected this massive pulse of carbon into the atmosphere, pushing CO2 to levels the planet hasn't seen in at least 3 million years. And here's what's so incredible. It's a total power imbalance. The cooling effect from those Milankovitch cycles is subtle. It's a gentle nudge. The warming effect from our CO2 emissions, it's a sledgehammer. It completely overwhelms that natural cooling trend, heating the planet way beyond the point where ice sheets could ever even think about forming up north. The consequences of this are just staggering, and they're incredibly long-lasting. Just with the carbon we've already put up there, we have likely delayed the next ice age by 50,000 years. I mean, think about that. We've skipped an entire glacial cycle. And if we keep going on a high-emissions path, we could stop ice ages from happening for 500,000 years, totally rewriting the planet's future.
And look, this isn't some fringe theory. The scientific consensus on this is crystal clear. Researchers at the prestigious Potsdam Institute confirm it. We've already done enough to cancel the next ice age. The natural rhythm of the planet has been put on hold. Our intervention has been that profound.
So, the globe gets warmer, the next global ice age is off the table. End of story, right? Well, not quite. Because while the planet as a whole is heating up, there's a wild card in the system, and it could plunge one of the most populated parts of the world into a sudden, totally paradoxical deep freeze. I want you to meet the AMOC. It's this massive ocean circulation system, and you can basically think of it as a giant conveyor belt. It pulls warm, salty water from the tropics up north, releasing heat that gives Western Europe its famously mild weather. That water then gets cold and dense, sinks to the bottom, and flows back south to start the whole trip over again. It is a critical piece of our climate machinery. But here's the problem. As Greenland's ice sheet melts faster and faster, it's dumping enormous amounts of cold, fresh water right into the North Atlantic. This fresh water isn't as dense, so it doesn't sink properly. It basically jams the gears of that conveyor belt, slowing it down and raising the terrifying possibility of a complete and sudden shutdown.
So let's be really clear here, because it's important to distinguish between two very different things. A true global ice age, the kind driven by Earth's orbit, takes thousands of years to build up. This AMOC-driven regional cooling event, it would be shockingly fast, happening over just a few decades, and it would primarily slam the regions around the North Atlantic.
And the effects, well, they would be absolutely devastating. If the AMOC collapses in a world that's 2 degrees Celsius warmer, that heat conveyor belt just shuts off. London, which usually has pretty mild winters, could suddenly see extreme cold snaps of minus 19 degrees Celsius. Oslo's winters could plummet to nearly minus 50. It would be a regional ice age in an otherwise warming world, a climatic whiplash that's almost impossible to imagine.
Okay, so we've canceled the global ice age, but we might accidentally trigger a regional one. But this story has one more twist, and honestly, it's the biggest one of all. New research is suggesting there might be a fundamental flaw in Earth's long-term climate thermostat, a glitch that could cause the entire planet to violently overcorrect for all our warming.
For millions of years, Earth has had this slow, gentle way of regulating itself. But the latest models suggest that when you hit the system with a massive shock of carbon, which is exactly what we're doing, a totally different and much more powerful mechanism can take over. A biological feedback loop in the oceans can get triggered that doesn't just stabilize the climate, it sends it hurtling in the opposite direction. Here's how it would work. Our warmer, wetter world washes more phosphorus, a key nutrient, into the oceans. This triggers these enormous blooms of plankton, which suck up CO2 like crazy. When they die, they sink, burying that carbon on the seafloor. But here's the kicker. This process uses up all the oxygen in the deep ocean. And under those low oxygen conditions, the seafloor itself starts releasing even more phosphorus, creating a runaway feedback loop. The whole system just spirals, burying so much carbon that it overshoots and could actually trigger a severe global ice age. Geologist Andy Ridgewell, who led this research, has the perfect analogy for it. He says it's like a house where the thermostat is in a completely different room than the air conditioner. The AC just keeps blasting cold air long after the rest of the house is freezing because the thermostat hasn't gotten the message. It's not a gentle rebalancing, it's a violent overcorrection.
And the timeline for this potential planetary overshoot? About 100,000 years from now. So in this absolutely stunning twist, after we canceled the next scheduled ice age, our actions might inadvertently trigger a future, even more severe one, right around the time the one after that might have been due anyway. The cause would be completely different, but the outcome could be chillingly similar. So where does all this leave us? We've got the slow, steady pull of Earth's orbit to try to cool us down. We have the massive warming push from our emissions. We've got the regional wildcard of the ocean currents, and now there's the potential for a long-term biological overcorrection. Let's try to put all of this together on a timeline for our planet's very deep future.
Okay, let's map this out. For the next 10,000 years or so, human-caused warming is going to be king, with that AMOC collapse as a major regional risk. Then, for the next 100,000 years, we will live through the canceled ice age. Orbital cooling will try to kick in, but our long-lasting CO2 will suppress it. All the while, that biological carbon pump will be quietly building in the background. And then, way down the road, the paths split. Either the planet overcorrects and plunges into a deep freeze, or if our missions are truly massive, we might just break the ice age cycle for 500,000 years. And that, right there, is the ultimate takeaway from all this. The choices we make in this century are not just about next year's weather or the next decade's climate targets. We are wielding geological scale power. The carbon we're releasing now is going to be a dominant force in the climate system for longer than our species has even practiced agriculture. We are, right now, writing the planetary history of the deep future.
You know, there's no natural baseline for us to go back to anymore. We've pushed the Earth into a completely new state, one where the old rules and the old rhythms just don't apply. We have become a primary driver of this planet's destiny. So the only real question left is, what kind of future are we going to choose to write?